Hi, welcome everybody joining us for our Google Hangout. My name is John. This is our first Google Hangout, so we may have some interesting technical things to work out as we go, but Elizabeth from Dexter Industries and Nicole from Dexter Industries are both live and joining me to talk about the GoPiGo3 and setup. Welcome, Elizabeth. Welcome, Nicole.
Great, thanks.
And Nicole, I think your mic is still on mute.
Yes, it was. Hello, everyone.
Welcome.
I didn't have the mic.
I'm gonna start by talking a little bit about the hardware and the setup. And Nicole's gonna follow up. She's our lead software engineer. And she knows the coding language inside and out. And from there, Elizabeth will maybe give us some closing remarks on. And in the middle, we're happy to take any questions for anybody joining us live that wants to ask questions. It's already sort of been through the whole experience or been through part of it, and I think we'll get it kicked off. On my list here. So we wanted to talk about assembling the GoPiGo, and I've actually have one fully assembled right here. I'm going to give a bit of a walkthrough, but we have directions online on how to assemble this and where to walk through to get all the how to get all the different pieces of hardware together. I've got a couple of things going on with this. I've got, you can see the starting from the bottom, I've got the clear acrylic case. I've got two motors attached with the metal brackets to the acrylic case. These motors, they've got some encoders, and I'll come back to just taking a look at those a little bit in just a minute. Make sure that your caster wheel, the dragging wheel at the end, at the back of the GoPiGo, this is the back direction and this is the forward direction. The caster wheel is on the same side as the motors. So you can see that caster wheel points down and the motors are sort of point down. We've got a Raspberry Pi on here. This is a Raspberry Pi 3, so it has a Wi-Fi, small Wi-Fi chip in the back. Can't see very well here. We've got the red Dexter Industries GoPiGo3 board on top, and that's what's going to control your motors, talk to your sensors, and relay information back to the Raspberry Pi. Last but not least, I've got a fully charged Dexter Industries rechargeable battery on the back, securely and snugly attached to the back of the GoPiGo3, and got some hardware ready to go. So that's sort of just a quick walkthrough. I want to point out one thing on the back. See if I can get this up to my my camera. These are small magnetic sensors, and then this is a round magnet that spins when the motor moves. These are for tracking the movements on the wheels very precisely. They're called encoders. What we want to make sure is that the encoders are snug up against that that magnet. You can see that quite well. If you find that any of them move sort of out of place or move away, or you find that a motor is not responding, the first thing to do is to check these just to make sure that they're close to the magnet, and that should be should allow the motor to operate properly. So I'll put up a link in just a minute that walks through the assembly there, and should have that. That should have come with the package that we sent out for code. Want to pause there and see if, like, Elizabeth or if Nicole have any feedback on that on my walkthrough. Did I miss anything? Do we have any questions?
I think we hit on the main points.
Okay.
So now, Nicole, did you want to share a bit how to get connected and program?
Yes, I will do that. Just making sure that my video is being shared right now. So we have two. Am I?
Yes, you're live.
I'm live. Woohoo! So we have two methods of programming this robot, and for that I will be doing a screen share. So while I set up my screen share, it's going to look weird for a second. I will do my best that. And then now this. There you go. So you should see here I have my GoPiGo is on the floor, and it is on. In the middle, you can see there's a green LED that tells me there's actually two of them. There's one near the back wheel, and there's one towards the front. The one towards the front tells you that the GoPiGo is ready to be connected to. So to connect to it, I will have to change the Wi-Fi of my laptop. Now, because I'm doing this Hangout, I have a non-standard setup. I have my Wi-Fi and an Ethernet connection, so it's not going to be exactly the way you will experience it, but it's going to be close to it. So if I go here, I can see I have a Wi-Fi called GoPiGo, and I will connect to it. I highly recommend not connecting automatically, because from one lesson to the next, you may not have the same laptop associated with the same robot, so it's just going to lead to confusion if you do that. So just connect to it. And if you're on Windows, it takes you to a browser. Because I have the Ethernet connection, it actually takes me to MSN. But you normally would not have that in a classroom. So again, to work around this Ethernet connection, I have to enter this series of numbers, which is 10.10.10.10. Normally, you would have mygopigo.com. This is what you would get in the classroom. But 10.10.10 is always a nice method if something goes wrong. This one is almost guaranteed to work anytime, and it works with my weird setup right now. So this is where you would land in the classroom. On the top over here, it says that I'm connected to the GoPiGo. This is the name of my robot. If you have many robots in the classroom, each one of them should have its own name to avoid confusion and to make sure that you're connected to the right robot. One thing to see in the video of the robot, that green light at the beginning has now turned purple, bluish purple. That means somebody has connected to that robot. So this is another method of knowing which robot you've connected to. It will turn blue when you connect to it. So if the kids do it one by one, then they know which one they're connected to. So the first screen that the kids will want to get into is the drive screen. So they can choose if they have a touchscreen to click on the buttons, or they can use the cursors on the board, on your keyboard. You don't need to hold it down. Just pressing it once is enough to have the GoPiGo go forward. Space stops it. I can bring it back to its starting position. Left, right, trying to get it there. Kids love the screen. You can probably get away with a full class if you give them a path, like a labyrinth that they have to, a maze that they have to navigate. It's a very nice first contact. Also, on the right hand of your screen, there's an emergency stop button that is present on all of the screens. And you have access to some feedback on the batteries. So I have the rechargeable battery on, so that would give me about probably still 4 hours of going on with that one. With rechargeable battery, it would be slightly less. There's a space here because I did not put a USB drive. I should have, but you would have feedback here if the USB drive is active, or if there's one missing, then you don't see it. So that's it for your first screen. You go back. You have a choice of going into Learn, where we have lessons, Code in Blockster, or Code in Python. The lessons for now are only in Blockster, the Blockster language that we have developed for the GoPiGo, and that is a block-based language. similar to Scratch, or if you're familiar, it is based on Blockly. So if I go and learn, if you do the first column, you have 3 chapters in here. They do not require any sensors. And then the others are for the sensors that you may or may not have. We have a lot of sensors. Not all of them have their lessons written for, but we already have quite a few in there. So I'm going to go and show you how the progression that we have. So in GoPiGo getting started, the very first lesson, first of all, we have steps that will explain to you basically what I'm going to explain to you live. So I'm just going to skip that. They are given a challenge to solve. And this current challenge, they only have 1 block to play with. So the challenge is program the GoPiGo to drive forward for 2 seconds and then back to where it started. So if I want to go forward for 2 seconds, kids will do this, but you can point out that they can edit this and enter 2 seconds there. And then they can go backwards by clicking on the down arrow and choosing backwards. I'm not too sure how big of a distance it will cover for 2 seconds. I don't want it to leave the area of the video cam, so I'm going to just keep it at 1 second. And you click on the run button, and there it goes. Your first program with Blockster. And then once that's done, you can go to the next lesson over here. You can keep on clicking through this. It will take you through every single lesson, every single chapter, where you can go back to learn and select a specific chapter. So this one, they're learning to turn 90 degrees. It's the same thing as before. They can either turn a specific number of degrees or turn a direction for a specific number of seconds. I'm not going to go through all of the lessons. We are going to go right into Blockster, which is where you would end up if you wanted to have free projects that are not limited to the lessons. So here you can see we have categories. Under each of the category, you have the blocks that are related to it. So we have a category that is very specific to the GoPiGo. You can drive it, you can set the speed, you can turn it, and you can open the eyes. I'm actually going to drop this one here to show you what they're like. If you can see the little Dex on the robot, it actually has 2 eyes that you can turn on and then turn off. And you can even change their color of the eyes. And let's make this one like evil looking. Right, that one doesn't work. Why is that one not working? Oh, because I'm closing it. Ha! Boom, red eyes. There you go. So it's always a nice thing when you're in front of the classroom to show that, yes, we can make mistakes. Our programs don't always work on the first try. And then we have to go back and look at what we've done wrong, because they will also make mistakes. And it's one of the things that programming brings into the classroom is resilience when you have challenges like that and you keep on trying it. And you don't have to feel like a failure, because failure is part of programming. Sorry about that. You will fail many times before you get your program to actually work. So one of the things here, and once you're in Blockster, that is kind of neat, is you have the sensor control panel. I have only one sensor on the robot right now, which is the distance sensor. So if I select it, right now there's absolutely nothing in front of it. It cannot read. But if I put my foot, then you can have the values. So you can see what it's reading live without any coding. And then if you go into sensors, you have blocks that will let you read that value inside of your code. We have a distance sensor, and we have a temperature, humidity, pressure sensor. We have a light and color sensor, and we have an IMU, or an airplane simulator sensor, so that you can, instead of having the robot on the ground, you can have your kids running around the classroom holding the robot and having it behave like an airplane.
Hey, Nicole, I don't want to interrupt you. Can you show us that one more time, where to find that live sensor? Because that's a really neat feature to see.
In the sensor control panel?
Yep, exactly. Yeah.
Okay, it will be open up when you get into Blogster, but you can close it and get it back up by clicking on this little top arrow over here. And if, depending on which port on your robot, in the front of it, you have 4 ports. The I2C, and 81, 82, and another I2C. So depending on where your sensor has to be plugged in, this is where you will actually get the information of where to plug it in. So the distance sensor shows up on the I2C. If I go over here, the distance sensor doesn't show up. So I know I cannot plug it into the 81 port.
Let me just show with my camera where those ports are here.
Yes,
I should have done that when I explained the hardware, but if you look at the front of the GoPiGo, you've got those 4 sensors, and you've got the I2C and in my camera. I'm pointing at 81, the analog port 1 here, analog port 2, and then another I2C here. So these are where you would plug your sensors, like the distance sensor, in right there at the front. And those correspond to what Nicole was just showing us in the software, how you plug those in.
Let me reset what I have. Can you confirm that I am sharing my screen properly?
No, we can still just see you.
Me. Why will you see me?
Which is great. I think you're probably going to press your screen so you can show us. There we go. Yep. There's me and something.
Okay, so you are seeing my screen right now.
Yes.
Okay, good. So another notion that you can bring with the kids is the difference between what is a sensor and what is an actuator. When I do that, because I do take the GoPiGo into the classroom myself, I talk about the 5 senses that they're very familiar with, but then I talk about the fact that we have legs that move, we have muscles that move, and our hands, but we cannot really do anything with our eyes. Our eyes are something that senses the environment, but I cannot really move an object with my eyes. I cannot have an effect on my surrounding with my eyes. So that is the difference between what is a sensor, it reads the surrounding, and what is an actuator, which is, it handles, it's like a muscle, if you want. And this one, oh, I didn't even double check. Let's see if it is connected. It has a little servo, which is a code name for a little motor. I'm going to set it to 40 degrees. Yes, it is connected. And now I'm going to center it again. So the distance sensor that I have in front is connected to that little motor called the servo. The GoPiGo comes with 2 servos. Right now I have 2 servo connectors. So right now that servo is connected to servo 1. And you also have servo 2 if you wanted to add another servo onto it. To get rid of a block, you can either bring it back here, or behind this, there's a little garbage can over here that I could bring the garbage can. Also of note, only the blocks that are going to be connected to your yellow starting block are going to run. If I have a block that's here, it's going to be grayed out and it's going to be ignored. Some kids get confused by that, so I might as well mention it. Let's bring back the little robot for a second. Right now, it is not equipped for that, but you can add a speaker to it and have a little robotic voice speak back to you. By default, the blog says hello, but you could change that to say something else, but I don't have the speaker on right now. And you can also have a camera. The Raspberry Pi has a camera that's available to it, and you can have the GoPiGo take photos. So you can create a folder to keep your photos, and then you can take photos. And when you want to see the photo, you would go into, on the sensor control panel, the top says camera with a little icon. Click on the icon, and it would take you to where your photos would be. For the camera to work, you must have a USB drive connected to the Raspberry Pi. So John, if you want to take over and show them where to put the USB drive.
I can do that. I have a USB. If we look at the front of the GoPiGo, you have 4 USB slots here in the front. And if you have any, say, standard, let's see if I can drag it, something over here, the USB. Any standard USB piece, you can just plug it right into the front, and that's where your drive will go. I think, Nicole, we think the best place to put a USB drive is over here on the, let's see if I can share that again, over here on the left side, facing forward of the GoPiGo3.
A short USB like yours could go anywhere, but the long one that comes with the kit, that's the best place for it. Yes.
Great.
Okay. Oops, why did that go down? You can move the workspace quite a bit. So there's room for a lot of things. And once the kids get to do a lot of programs, there's a zoom out. And there's a zoom in. If they lose their parts, like they have logs that they don't know where they've gone to, zoom out and zoom in are useful. Now for a little bit of more advanced programming, if you are familiar with what coding is, you have conditions under logic, a simple if or an if-else, and then numerical conditions. If you down click on this, you can change if equal, not equal, less than or equal, greater than or equal. And then you have logic. So if something is true and something is false, you would have to replace the true and the false with a sensor reading. And you can go into loops where you have how to repeat something. So this would repeat 10 times. This would repeat while a condition is true or until a condition is true. And this one is usually used with the distance sensor. So after the repeat until, I need something that is true or false. And under sensors, I can have a choice of reading the actual value from the sensor or getting a true or false back from the sensor. So I'm going to use the true or false. So repeat until the distance sensor, it reads less than 5 inches. So there's something in front of it. And I'm going to, what am I going to do? Okay, open the eyes. And then close them. So right now there's nothing.
So Nicole, before you run it, what should that code do? Can you walk us through that?
Yes, that's what I was going to do a walkout. It will make sure that the distance sensor faces forward by setting the servo to 90 degrees, which is straightforward. And this is going to repeat basically until there's an object in front of the distance sensor. So we're going to basically keep opening the eyes. It kind of makes no real sense to just say open eyes, open eyes, open eyes. And then once a distance sensor is detects that there's something closer than 5 inches, we're going to get out of that loop and then close the eyes. So let's try it. Right now there's nothing, so the eyes should open. Boom. If I walk in front of it, I'm about 5 inches away, the eyes closed, and the program ended. So that's it for loops. Honestly, this loop that I just did I I will lose beginners explaining that loop. So if you are a beginner and you didn't understand that, you are perfectly normal. This is a more advanced concept because it's a weirdly shaped loop. They are loops that are simpler to understand, like repeat for the next 10 seconds. That would be easier. So let's say actuators. So repeat for the next second. Set the servo to 45. I'm going to skip the time. Time is a neat block that says count 1 second. And then center servo. So let's see what this one does. It starts the servo in the middle. And for the next 10 seconds, it's going to bring the servo to 45 degrees to the left. Wait a second, center it, and I need another wait second. I'm going to get this.
So you can see on your robot, the servo is moving back and forth there.
Yep. So that is an easier loop of what it can do. And then if you want to, you have advanced math. There's some pretty, like there's a remainder notion, there's a constraint, rounding, you have a sine wave, cosine, square root, absolute, logs. So there's some pretty advanced math that you can do. And you can also print. So let's do this one again. So for 10 seconds, we're still going to see the loop. That's going to take 10 seconds. And then I have this output window that gives me the print statement that I had. And done is just a confirmation that the program has ended. Then I can click out of it. So this is what the print does. We could have the print in here, and it would show up every time the robot moves. Now we had many hellos because it was part of the loop. If you feel that you are getting limited in Blockster, we have a mode called Advanced Blockster. Advanced Blockster has more blocks for you to play with. And you can see that some of them have like subcategories. This is what that little arrow over here is. So I have more blocks, and then I have light controls in a separate area, and then we have motor controls if you want to be able to really precisely control your motors and know which distance you've traveled. Under sensors, we have blocks for the line follower that are specific here. We have the same true or false like before, but we also have data logging. So if you have a sensor like the temperature, humidity, pressure sensor, you can actually log that information onto a USB drive so that you can bring your experiment values into Excel and do graphing after that. And the rest, well, some of them are more complex, but not much. But also you can create your variables and you can create functions. So with Blockster, you can actually get quite far with various programming lessons. And once you reach the end of Blockster.
Hey, Nicole.
Yep.
We had a question come up, and it's a good one. Are there?
So good.
Not sure if you can hear me. Yeah, sorry. Are there template coding lessons to use as guides while doing the programming?
If there are templates lessons?
Well, we have some example code in some places, right?
Well, no, we have some examples in on our website, but not in the robot itself. What we do have are lessons that will take you by the hand and walk you through some things, but we don't have samples. I don't think so.
Right. So in Learn, we have examples there on how to get started with some code, and then we also have some code is written out, I think, on our studio.
Yes, in the studio, you will have cases where code is displayed, just not on the robot itself. So this is the beginning of the first lesson where you only have one block. And then you walk through the second lesson. This one has little 3 blocks, etc., etc. And they get more complex as you go on. I'm going to go back to Advanced Blockster. So let's just, one thing is of note between regular Blockster and Advanced Blockster. In Advanced Blockster, this drive forward for 1 second, the 1 has the shape of a block. That is because I can actually replace it with a variable if I wanted to. There's a variable here that I could drop in. Or I could even drop in a sensor value. It kind of looks weird that I'm going to use a distance in inches and put it into seconds. But that is just because I'm trying to show you what this weirdly shaped block is used for. I could, for example, do math on it. So I could have the distance sensor value in inches divided by 5, and then that would give me something in seconds. Again, for more advanced users, this is why it's in Advanced Blockster. In regular Blockster, I'm going to go back to regular Blockster. This one, while I can edit it to be another number, I cannot drop a value from a calculation or from a sensor into it. So this is one of the differences between Blockster and Advanced Blockster. I've done a lot of lessons with this, and depending on the age and what the kids already know coming in, you can do a lot staying in Blockster and never moving on to Advanced Blockster. But we always have this one kid who's done a lot of Scratch and probably has robots at home, and that kid is ready for Advanced Blockster. So you can send that kid into Advanced Blockster while the others are staying in Blockster. Again, for the more advanced kid or for older kids, your Blockster code generates Python code. And you can see here the Python code that gets generated by the blocks. And if I were to change the seconds to minutes, well, my 5 minutes is actually 300 seconds. Calculation is done for me. Or I could even change it to centimeters. And now we have a totally different function that's being called to get 5 centimeters away. Which actually, if I were in Advanced Blockster, now that I think of it, I could use my distance sensor in inches and then change it to inches. Why didn't I think of that before? So now it would drive forward for the value that is being read and change that in inches. So it would basically drive forward until it touches the object. It would stop just as it touches the object. So this one makes sense over here. And you can have that. You can see your Python code that gets generated for that. What is neat, once you're ready for that, is I can actually do a copy paste of this. And when I go into code, I can go in Python. And we support Python on this robot. I'm going to create a new file. Test. I can put my code, and I could add more to it because it gives me Blockster gives me a base. Then I can go on and change whatever I wanted to change in the code, and then I can run that from here.
So Nicole, can you show us what you just did one more time? That was really cool. So you generated some code in Blockly. You went over and made some Python, and then you pasted it into the Python editor.
Yeah, pretty much what I did. Like say turn 90 degrees. We didn't talk about blinkers yet. Underneath the robot, you have two little red lights that you can use to basically just like blinkers on a car. Just one more thing that the kids can play with.
I'll show you where those are really quick. They're, if you look on the board, they're right there. Those little LEDs. You can see that. One blinker there and one blinker there.
And let me try and reshare my screen. So I've dropped, right now they're pretty much random blocks. I have the Python that gets generated over here. And I can take this, go in Python. It's my test file. And there's the code. And now I could add some code into there. So it's an easy way of getting started with Python because you can have the shape of your program done with blocks and then just change a couple of things in your Python code. And you can transfer more easily from one to the other. One thing that's really neat, well, I think it's really neat, is really, I didn't save the code, so I keep losing it. If I show my Python over here, it is actually changing live. I can move them around. You can see the code changing. As soon as I connect it, now it says if true pass. Why pass? Because there's nothing in here. So let's put a test instead of true. So to do this test, I actually needed to create a distance sensor. That's done automatically for me at the top. And now I have my test over here. And I will use that. I'm just dropping blocks randomly just to show you that they get generated on the fly. I have no idea what that program is supposed to be doing. If you don't understand the program, it is perfectly normal. I don't either. So I think we've pretty much done a good workaround, a good look around everything that DexterOS 1.3 offers you. There is one thing I haven't talked yet. If you have more kids, more teams than you have robots, the kids can go to online on another laptop. They can go to blockster.com. This is really online. It is unrelated to the robot. It says here, no robot connected. And they say, I can start coding in Blockster. I own a GoPiGo3. And boom, they get Blockster. So they can build their program over there. Once they're happy with the program, they can download the code that brings the program onto their laptop. Once they get access to the robot, they can go under File and upload the file from their laptop onto the robot and be ready to run. So if you only have a few robots and you have a classroom of kids, they can keep busy working on their program. They just cannot actually test it until they get their turn on the robot. And I think I've covered everything I wanted to cover for now. If there are any questions, I am open to them. I hope you enjoyed that little tour around.
That was a great walk around the entire operating system and what you can really do with Blockly. Thank you so much, Nicole. Elizabeth?
Yeah. So, and then from there, if you're interested in seeing we have a repository of premium curriculum and free projects, and that's on Dexter Studio. In the email you'll see that we sent you, you'll see that there have been accounts created for you, and everyone right now has the same password. You can go in and change that, but the username is your email address, and then Dexter in capitals 1 2 3 4 5 6 and an exclamation point. And the website that you will go to for that is studio.dexterindustries.com. Let me see if I can share my screen as well here. So if you see that, this is what Dexter Studio looks like. You can then go into projects. And then what I like to do is then head over to the right-hand side here, the filter button, and you'll see all the projects for your GoPiGo, and you can filter them by grade, put in your minimum grade and maximum grade that you would want, whether that's, for example, we'll do 5th grade to, let's say, 7th grade, and it will filter through and show you the projects that are geared toward those grade levels. We can get rid of that too. Actually, let's see if I can to show all of the projects, or you could search by duration of time that you have to do the project. You could also search by how it's been tagged if you're interested in some of the other languages, or if you want to look at biology or computer science or art, or education standard. So if there's a standard that you're looking to find a project that fits that, you can search there as well. So you will find everything for curriculum in Dexter Studio. Yeah. Great.
Great. Thank you so much, Elizabeth. I think that's about all that we had scheduled that we wanted to talk about. So we have a few visitors, and if anyone on the Hangout wants to ask a question, stick around for just a little bit and hop back around. So Nicole, Elizabeth, did we miss anything else that you all wanted to talk about?
I don't think so. I think also if people have questions along the way as they're building and programming, please feel free to reach out to us and we can help you as well through email.
I would just like to add one little thing. You have been sent DexterOS, which is the OS that we favor in the classroom. However, the robot can also be run with Raspbian for robots. So when you look for a project, you might get confused if you're looking at Raspbian for robots without realizing that it exists. And Raspbian for robots has a support for Scratch, but connecting to it is not as easy. Connecting to the robot is not as easy as with DexterOS. And using Scratch is not as clear as Blockster can be. So we favor Blockster, but if you look in Dexter in Studio or online, you may find projects that use Scratch or other languages. So just don't be confused about that. We do support a lot of things.
That's great. Thanks, Nicole. I think at this point we'll wrap this up and we will save the broadcast so that we can share with other folks that may not have had the time to make it. And we'll look for your feedback. If this was helpful for anybody, please let us know. Contact us. We can look into doing another one, and we can look into other ways just to try to support you to make sure that the whole hour of code experience and the whole experience with the GoPiGo and DexterOS goes smoothly. So thank you all, and good luck with the coding and good luck with the robots. So bye.